So hi people. Um, in 1977, David Bowie released Low, one of the most amazing albums on the humanity, and one of his best probably. But this album has a song called, a music called Sound and Vision, which is this kind of creative, I don't know, or maybe, I don't know, cliche cover on the remaster. And today I will prove to you that back in 1977, David Bowie was predicting the APIs that we have today on browser. So my name is Rafael, I'm from Brazil. I'm living in Berlin for like 5 months, and I am a telecommunication technologist. I graduated as and learned some stuff about signal processing there. I work for a company called 12 Traits that we are improving the way that user experience is connected, and like how to have better user experience while people are playing. So we are helping company to improve their games based on user psychometrics. It's pretty cool stuff, yeah. And we can talk a little bit more, but I will start with the vision part then. Canvas is one amazing API that you can use it. People do very cool stuff with it, like even games, like there is some sort of nice stuff. And one of the things that you can do with Canvas is load an image to it, and then with the onload callback, you can draw the image based on the size of the context and get the image data. When you do this, you have this big array on the called data that gives you all the information about pixels, RGBA, like red, green, and blue, information of each pixel, and then you have alpha. So you have these big arrays that's kind of, this big array that's kind of different, a little bit difficult to spot, and like where is the first line, where is the second line. But yeah, you can do some really cool stuff with it. If we plot this array, doesn't have many information here, looks like a saw or something. And this is kind of not useful because when you have RGBA values, the alpha is almost like, it's very used to be 255. So you have all this information that's not really useful. Even if you remove alpha, sometimes you have red, green, and blue way different from each other, because if they are close to each other, they are gray. So here you have the first line of the cover of low, and it's kind of, I don't know, it's hard to spot what's going on there. But if you go through the array and split the colors in different arrays and you plot together, you can see this is the first color separated by, this is the first line separated by color, and you can see that you have the lines red, green, and blue, and you can see that all fall together to 0, because you see on the first line you have this small, a little bit darker color there. So it's cool because you can see the information. And here you have one line that's, I think that's 200, that it's all happens to fall together because the Bowie's sweater. So nice. We can have these arrays of color. Doing a little shift, and the meetup is about that. Let's talk a little bit about Web Audio API. Here are some nodes that I'm using together. That gain that's not aligned here is kind of okay. So we have delay, media, oscillator, gain, buffer, convolver, web shaper. I will do better introducing to each one, but basically we can connect our microphone to the output, like the speakers, and adding some of these nodes in the middle on the path. So one of one of the coolest stuff that we can do, like, yeah, we can do a lot of cool stuff, but this one is kind of nice because you can basically create a buffer. This is like we are creating a buffer with a function there that is seen of 300 hertz. Like we are basically doing something to populate an array with a specific sample rate that is the standard on browser is 40,000 for 400. So then we can create this buffer source here, then create a buffer, get the channel data, and like write the values of the array inside the channel data. You probably know a more elegant way to do that, but the thing is, and we can like assign to the buffer and connect to the output. So I will switch to browser now because. So my first demo here is like to make array sing. So this can be kind of annoying, the sound, so I'll try to like, let's see how it goes. Geez, this will be messy. So here we are seeing the array with 300 hertz, and this is 2 versus P, rounded, yay math, but the thing is like I can create a tune with that. So yeah, I need to control this volume maybe, probably. This will be, okay. So here is 300 hertz. I can use a higher frequency. So this 300, this 600, and then if I multiply this scene by like a exponential function that is like decreasing, I can have it's kind of a beat, like, and then there is something that I can do with random values that will add random and it will look like noise, but also looks like a cymbal, so I can do. So yes, we can have like drums playing like with math, and then if we do the same thing like with a differential exponential and like adding one to the frequency, which means that we are adding Doppler effect to these, we are basically doing a laser gun. So the things that are like the difference between a drum and a laser gun is basically frequency and Doppler effect on the sound. Like that's, yeah. And if I have, and depending if I know the equations that are supposed to build any sound like a violin, I can build anything by synthesization. So yeah. And this means that we can use arrays to create sound. So if colors are arrays and music can be used by can we hear a color? Yes, we can. It's not pretty. It's far from pretty, but on this day, on my talk, you will hear things that are even worse. So these are, yeah, that's enough, right? It's like, this is a color, the red color of the low cover being played, so. And now that we have like, we can do equations to modify sound, and we can have like colors to do this, we can do like equations to change the canvas also. So here is like a really basic filter that I'm implementing by remove the green and the blue color on the cover, and I'm getting this value here to change the value of the frequency. So here is a very basic filter that, depending on the value of the range, will like change the colors on the cover on the final. But here I'm replacing green and blue and adding like 90 degrees difference between. So yeah, because sine and cosine. So yeah, we can do really like primitive filtering by adding these values. So, and the thing is like the image keeps there because the red. So yeah, we are keeping that, and so we are able to remove these the colors and like change canvas by doing math functions, which is kind of awesome. And the thing is like the image has values from 0 to 255, the colors, and the audio can handle values like that's like louder than these, but maybe it can value like from -1 to 1. So in like an average, if you're not using gains or any node that will amplify, as expected. But the thing is like if you notice, the music is like pretty awful without the lower notes. So show some loves to your friends that are bassists, drummers. These people deserve all love. And so yeah, let me do this. Okay, this will be okay. So this is the input in orange is like the original sound, and the output in white is the sound, like the output of the low pass filter. So if you see, the effect is like basically the low pass filter opposes to high amplitude variation. So every time that amplitude like varies really fast, the filter go there and do a smooth depending on the values. But this is basically what the filter do. The low pass one. So I get the 3 colors of the image, split it, and then pass it through filters, like one by one. And the thing is like, if you think about smooth, the values, like the cause like this smooth will be applied to pixels, because if you see the transitions between colors, this one is easier. The transitions between colors are like blurred, and that's what a low pass filter do with pixels. Is like, because math works for sound and vision, or like sound and image. So this is like it's cool to see that we are basically applying filters when we are like doing Instagram stuff in many ways. So, and this is a little bit hard to note, but high pass filters will only stays with the high transition. So every time that an amplitude like varies fast, we are just staying with that. So you can see right here that the low pass, the low frequency component was removed, and we have only the high transitions. And when you do that, you apply, you only have the points where the pixels change like a really good value. So this should not be gray. It should be black. But the thing that I do to move the values to 0 from 255 to -1 and 1 are doing this gray stuff. It's kind of, I have an article that's the background is black, but the thing is, if you take the sky that is all blue, there is no variation from like blue points. So we are removing the parts that are not varying really fast. So the parts that really fast is like the color change, and then you can see the clothes here that the colors change fast, or like you only have the contours of the image. So it's kind of, it works without this gray stuff. But so yeah, this was basically filtering, and I was checking a talk about a guy, but let me do this. So I promised you that you hear something worse than a color being played, and I want to do a disclaimer that I've been part of many bands in my life, always as a roadie, because people will not invited me to play in a band because you notice why. But here's the thing. It will be short, so don't run away. I was checking talk about this guy, Sam Bellen. He was doing an entire guitar set and on his talk on JSConf Budapest. And like I already had the filter stuff, an article, and I was saying, what if I play stuff in other kind of nodes, not only in filters? And so here I am adding a delay filter between the microphones that's connected on my interface here and the output. So it's not really like only add a delay like that. It's not really useful because no one will play something without any feedback like what I'm playing now. So yeah. And the thing is like for a pedal is not working good, but when you do the same process like to use colors, pass through the node, you have the waves will do only a time shift. That's like a delay. Okay, it's working properly. And you see when you get all the colors together one by one, you get this image that is shifted. Like, so we are basically a delay shift, which is a time shift. When applied to image, we'll like basically shift on space. So we are removing things on canvas or like depending. So here's the result. And yeah, you can see like the things that are connected, like the other part of the image is here. So you're basically shifting. So that's because the colors are a big array. So we're not shifting the entire line. If you add a really big value of delay, you can see that are like you are basically removing to the left to right and on the from top to bottom. Yeah. So adding a little bit more useful delay stuff, we will add a direct path between the input and output, and then add our other path to the delay, which will cause. I don't have a graph to this. Oh, I'm sorry, it's the same. Okay, so here is how expected it works like. I'm kind of noticing a little bit like, I don't know if it's the HDMI or something like that, but yeah, I can remove a little bit and yeah, and then depending on the value of the delay, I can hear or not the other guitar. So, and when I apply that to an image, it's cool because you can see the original path, like the original image, like no movement, and then you can see the echo, like the delay part, being plotted after that. So. And one cool stuff that you can see is like the image is like the sky there is a little bit bluer because at some point the images will like superpose and will cause saturation. So depending on the value of the delay, we will have like you shift the image like a little bit more depending on the position. So yeah, and then we can add this configuration, which is a delay that is retrofitted. So that you have the same direct connection from the input to output, but then you have a delay, and then you have a gain, which are like connected back to the delay. So this will cause this effect here. So you have only 2 oscillations in orange, and the output will be all this. Like you can see a looping, you can see that things will like repeat, kind of. And depending on the values, we have these. Okay, this will be interesting. And yeah, where's my looping? The thing is like it's very easy to find like in a constructive looping that's like will be sound forever, at least until your hardware support. So and you can see all these notes that are repeating there. The thing is, like, when you do this to an image as you like expect, kind of, you can have all these repetitions. Like, so you see the looping going on, and depending on the value of the delay and the gain, you have all these different images superposed, and it's crazy because you can see that are kind of in phase here. So you have so many different images, and the images are losing amplitude. So there are some effect it's kind of cool to see. I already came home seeing things like that, but yeah. And then we have this really complex pedal that's called flanger or flanger, I don't know. We have this gain connected to a delay, connected to a gain, and connected back, which will give us a looping. And then you have this oscillator that's connected to a gain and connected to the delay. So basically, we have something that can oscillate, but okay. And well, and you can see the oscillations going. When you do this, it's nice because, like, depending on the value of the gain and the oscillator, you can see all these phase changes depending on the values you have the yellow or the white. So yeah, it's nice to have all these. And when you apply to image, you can see the oscillator doing some distortion on the image, and you can see the retro delay repeating this distortion. So it's kind of really cool stuff. Yeah. So this is the reverb. Is kind of awesome. It uses the convolver node. The convolver node it's really peculiar. On this case here, I'm using audio to say how this I like basically copy pasted from the Sambelling repo that you should totally check, and it's basically a guy that is clapping inside a church, and he recorded the noise, like the sound, and you pass the sound to the node, and it works. Like it's insane. So you have these. And the cool thing is, like, the output is, you can see that there are some phasing, and it sounds for a really long time, changing amplitude, changing phase, kind of doing some really cool stuff here. And when you apply that to the image, you can see these. So phase are destroyed, amplitude are destroyed. There are some cool pink here. That's like a cool shirt idea, but yeah, it's like do a pretty messy job. I was like, yay. So yes, for last but not least, you have this wave shaper pedal, which is kind of a really, like, this name is like, wow, wave shaper. So this pedal, you basically you set a curve to it. A sigmoid function works really well, and this is kind of a scale here, so the white is like less distorted, and the orange is way more distorted. So the transition to 0 will say how distorted is your signal. So the orange signal are all these bands that probably are so evil that are font or distorted also. So yeah, the white one is like Rolling Stones, and the orange one is like these amazing bands. I know like Cannibal Corpse and Dimmu Borgir. I really admire that how this guy plays, but yes, like it seems that sometimes distortion can change fonts. Or so here's the wave shaper, and depending on the value of the curve, you have these. So and the thing is like if you add a little more distortion, so here we are. Depending on the value of the curve, it will round the orange scene to a value that is like depending it's or from yellow to white. The white one is more distorted, so like you almost have a squared wave. No fast moves, but here is the output. So depending on how distorted it is, you basically are rounding the values of like, so you are removing the values that are intermediary, so you have like a really stealing the happiness of the image. It kind of reminds so much some bands, but okay, now I will like not play anymore to like stop to harm you with my guitar. And down, okay. So, nope. This one I was trying to do some processing stuff, like pre-processing, but I was like doing some effects to do one of the things that I most like, that is chiptunes. And I was like, wow, what if I can reprocess that like in real time? It would be a really real pain, but so I recorded that one and added this process. This is not David Bowie, but the thing is like, if you get the orange signal and like round the values in between to like to have only 8, so 8 bits, it kind of do these square stuff, and it sounds like really good, but add a little bit of noise, so it's not a really big way to do that. But when you see the result, and please ignore that image is like a little bit like shifted, but I was really happy about the sky around it, because it reminds me a little bit one of my like favorite games all time, that's Gunstar Heroes, that has the same vibe on the sky. And the thing is like now you can use WebAudio API to play the music of the game and generate the cover at the same time. I don't know. So yeah. Okay. Now I was really thinking about how to finish this talk, because this is not good. I was like, don't do this in production. It's not a like really safe way to process images. And all the images are interpreted as sound, so like it basically takes seconds to process an image that's low. It's a really small image, will take seconds, because the WebAudio API is, we are playing audio, so like we'll play things like 40,000 samples will be played in 1 second. So don't do this in production, because it's like not safe, and but you can do for fun, because sometimes like it's cool to have it's cool to use code to have some fun, not only to work. So yeah. And but my biggest takeaway here is like I think that David Bowie sang a lot about how was to be different, or not to be like in standard. And I think that our community gave some really good steps on like to not to embrace difference. But I think that we can give one like more good steps on that. And I'm saying this as like a white privileged man. So this is my biggest takeaway here. And yeah, thank you so much. And one more thing, we are recruiting on 12 trades. So if you are interested, thank you so much.